Hello guys, in previous tutorial part 2 we saw about undirected graph representation using adjacency list. Now we are going to see directed graph representation in adjacency list. Okay, first of all let's remove this. Okay, now this graph is a little bit modified. Okay, here we go. There is a flight from Addis to Cairo in this case, which is represented with this arrow from Addis to Cairo, but this graph shows us that there is no flight from Cairo to Addis. It's only one directional flight. And here also let's modify this. There is a flight from Cairo to Bahar, but no flight from Bahar to Cairo. and another one is, let's do this toward this. Okay, there is a flight from Bahar to Addis, but no flight from Addis to Bahar. Okay. Okay, and then next, okay, there is a flight from Addis to Khartoum. Okay, okay, there is a flight from Addis to Khartoum, and what is represented with this. There is a flight from Addis. Oh my god, this is there is flight from Addis to Khartoum, but no flight from Khartoum to Addis. Okay. Another one is there is flight from Khartoum to Bahar, but no flight from Bahar to Khartoum. This is directed graph. And how do we represent this directed graph in adjacency list? First of all, the same thing happened like the undirected graph in case of creating an array of okay, the same thing is done like directed graph. We first have to create array of size 4. How? This is what is done. First what we do is the same thing, no change here. Also we do have 3 data to store on a given node in case of directed graph. 3 things: a pointer connecting the 2 cities, the name of the cities in the node, and the time cost taken between the 2 cities. Another one here also friend class graph, and this graph can inherit the whole variables of the node class because of this description. This description enables the graph class to inherit everything within this class. And then unless we store data in the node, by default it takes this one. If we store the given data in the given node, just passing the data as a parameter, just like city and the name of the time taken, the flight time, by just passing parameters just like city and flight time, we can store the given data on the node. So city is stored on the node, flight time is stored, and then since single node is alone and it doesn't have a next node, its next is null, so everything the same. Now in the graph class, what first happens is an array of size 4 is created. Pointer of array of size 4 is created like this. Okay, where is it? First, an array of size 4 is created using this node, using this description node asterisk here equals max means. In our case, max is 4. An array of size 4 is created with nothing inside. Array of size 4 is created first index, zeroth index, and this is the first index, this is the second index, and this is the third index. For array of size 4, the index goes from 0 up to size -1. Therefore, okay, this is what's created using this, and this is already found in the graph class. What is n? N determines the size of our graph, and this size comes as a parameter of this constructor. A programmer can send parameter of the graph as a parameter, then that parameter determines the size of the graph. In our case, that is 4. Okay, what's 10? Now the graph class creates an array of size 4 and then determines the size of the node by just passing this and making this variable equals this parameter, just using this line, and then it makes the whole array equals null. It initializes to null, indicating that nothing is stored inside it for the first time. So this line makes what? What does this line make? It just stores everything within the array null. It stores inside it null, no data at all. Null, null, null. Okay, then what's next? Okay, an array of size 4 created, and then everything within it is initialized to null. Next, we have to store all those series within this. No matter to which direction there is a flight, first of all we have to store all those 4 series within this array of size 4. So this is achieved by this function, and I'll show you that just like what we did previously. Okay, okay, where is it? Okay, here we go. Void graph, read data int gtype. Anyway, let for okay, what is this? Okay, where is it? Okay, let for the first time, for the time being, comment this and just say string temp cd. Okay, I'm going to show you how to store all those 4 CDs within this array, and this is achieved by this. Enter the CC details, and then this for loop populates all the array index with the name of the CD. First, I start from 0, I is ni++, then to store the first node on the 0th index for the first time, node has to be created. Always insertion takes place in the form of node. Therefore, to store address into this location, first of all, node has to be created, and the name of the city should be stored on that city, on that node first. Therefore, for the zeros index location, that is for this location, for this location, what happens? Head at 0 equals new node. Node is created at this point, and then it asks to enter the city from the keyboard, and then you enter from the keyboard. Look at, you have entered the city from the keyboard, and then it makes what? Head at 0. Node is created for 0's index, and then head at 0 right arrow city. The city to be stored on the 0's index equals to the city coming from the keyboard. Then you store at this in this location, at this. Where is it? Why this is happening? Okay, here now. Okay, there is something I have removed, so I have to return it here. So the name of the city should be this should be written here. Why? Because here at 0 equals city. Here the city at the 0's index equals to the city coming from the keyboard. And then I increment it to 1. Then for the index 1, node is created again. And then it asks you to enter from the keyboard. And then you enter from the keyboard and store on this variable. The name of the city is stored on this variable. And then next, here at 1, at the first index, the city to be stored on first index equals to the city coming from the keyboard. That is in our case what? Cairo. That is, oh my god, this is Cairo. No matter to which direction there is flight, first of all those nodes should have to be stored within this array. And then what follows next? I increment to 2. That is, I increment to 2. Then for the second node, for the index 2, node is created, and then from the keyboard, node is inserted, a city is inserted, and then at index 2, city at index 2 equals the city coming from the keyboard. That is in our case what? That is Bardar. And then what? I increment to 3. For the third index, node is created. Then this variable takes from the keyboard, and that variable stores the city on index 3. Therefore, on index 3, what is stored? Khartoum. So we have stored all those cities on this array. What follows next? This is the big thing that we have to consider here. The next step that we are going to consider is what differentiates directory graph from undirected graph. And this arrow plays a big role for this. Okay, don't forget, in last tutorial I told you about source pointer. Always, whenever current location or the source pointer's next is null, whenever the source pointer next is null, we only add the cities to the given city as flight path. Anyway, okay, now what we have to do is just see this. Let's go to the let's go to the code that makes insertion for the direct graph. Direct graph implementation is where it's found here, I think. Okay, look at this is a code that makes that is direct graph implementation. This is implementation of direct graph. for the flight path planning that we are going to see. Anyway, what does it do? Let's see the parameters that are included within this function. CD1, from which the flight is going to take place. CD2, flight is going to happen from CD1 to CD2, and this is the time that it takes from CD1 to CD2. First, what we have to make? We have to create a pointer with the name source. In last tutorial, we were creating two nodes during insertion time. But in this case, in direct graph implementation, we are going to create only node for the destination city. What is our destination city in this function? This is the source city, this is the destination city. We only create a node for the destination city. Node type asterisk. By the way, this node is the class that we implemented previously. I told you about it. Node type asterisk destination 2 equals new node cd2 time. What does this mean? The whole this creates node, and the address of this node, within the memory is the address of this node within the memory is referred by this pointer. This pointer is an address to the whole this node. Therefore, don't forget this, the role of this one. Okay. To plan flight from CD1 to CD2, we have created a node, and then next, before planning flight, first of all, does the CD1 really exist within the array? Does CD1 really exist within the array? We have to check. Does CD1 really exist within this array? If it doesn't exist, we are not going to plan flight. First of all, what we have done is, our criteria here is we need the cities to be in the array so as to plan a flight. So once we miss the given city, the source city within this array, we are not going to plan. So what we are going to do is, first of all, we have to just check whether it's available within the array or not. So int index1 equals get index of cd1. By the way, I will tell you maybe in the next tutorial how this function finds the given city within that array. Therefore, int index1 equals get index of cd1. If it's available within the array, the value of this will be greater than or equals 0. Unless otherwise, this function returns -1. If index1 equals -1, cd1 isn't found within the array. Therefore, we say no flight from cd1. No flight from cd1. If the location of the cd1 is not available within the array, this return type is -1. If it's -1, we display no flight from cd1. What if this cd is within the array? I mean this one. Let's say I want to plan a flight from Addis to Cairo. From Addis to Cairo. What is my city one? Addis. What is city two? Cairo. Don't forget this. So Addis is found within the array. So it's found in the array. Therefore, this part is false because it is found. Addis is found in the array. This part is false. Therefore, if that is false, inside this is executed. What does this part do? First of all, there is a pointer called source. This is the name of a pointer, which is going to start from the location of the cd1. What's the location of cd1? That is determined by this variable. We have seen that this function returns the address of the cd1 within the array, and the location of cd1 is found on this variable. So here at end1 means that is the exact location of where the cd1 is found. So source is equal to the location of cd1. So source starts from cd1. This source variable starts from cd1, which is currently what? Addis. Addis is the source cd, and we are going to plan a flight from Addis to Cairo, and Addis is the source city. So what we are going to do is the source node next different from null? We are going to make a flight from, we are going to make a list here. We want to just make a list here. This is an array. Each index of the array can have its own list. Does Addis have any connection with other node here as a list? No, it doesn't have. So source next is what? Null. Implies that city Addis doesn't have any node next to it as a list. Therefore, source next is different from null is false. That means source next is null. Addis doesn't have any node next to it. So if so, we can directly attach any city to the Addis city. Any city to the Addis city. So source next is null. Okay, I'm sorry. Source next is null. Therefore, we can directly attach source next equals to destination 2. So source next equals to destination 2 means source is the location of Addis. Source next equals to destination 2 means source is currently where? It's here. Source next equals to directly we connect to the city 2, which is Cairo. Therefore, because of source next is different from source next is null, we can directly add city2 to cd1. We can directly make what? This is node. This is node. Which node? Which were created here for the city2. We have created node this for city2, and immediately, since source next is null, we make source next equals to dist2. Dist2 is dist2 is the address of this node, which is Cairo. Therefore, this is dist2. This is dist2. So this is Cairo. Cairo. So we have made a flight from Addis to Cairo. Addis to Cairo. It's one-way flight. If it were two-way flight, that is Addis to Cairo and Cairo to Addis, there should be Addis should have to be also next to Cairo here. Addis to Cairo, Cairo to Addis. In this case, because this is a direct graph, only one flight path is followed. Okay, next. Okay, well, next what we do is Addis has a flight from Addis to Cairo, but another flight from Addis is to Khartoum. This time, how do we do this? Addis has a flight to Khartoum as well. So this time, what's our cd1? cd1 is Addis, cd2 is what? Khartoum. So cd1 is Addis, cd2 is Khartoum. So we create a node for cd2. This is Khartoum, and the address of this city is stored on this pointer. So first, what we check is the cd1, which is Addis, found in the array? We have to check. If it is not found, we are not going to make a flight. Therefore, if it is not found in the array, we are going to display this. If it is found, what are we going to do? what are we going to do? We are going to make flight plan from city1 to city2 if city1 is available in the area. Therefore, to do this, look up. Source should have to start from the location of city1. What does this mean? Source is a pointer. which holds address of the city1 always. So we are going to plan a flight from Addis to Khartoum, but where can we insert Khartoum so as to plan a flight? Therefore, first insertion should have to take place next to Cairo. To do this source pointer should have to search the last node. Unless we reach to the last node cannot be inserted to this. Addis cannot have additional node next to it unless we find the last node. So this source pointer should have to search the last node, and then we can insert Khartoum next to Cairo so that we have a flight from Addis to Khartoum. Therefore, once source pointer reaches to the last node, we can directly insert Khartoum next to it. What does this imply? The advantage of source pointer is just to find the last node. Therefore, to find the last node, first of all, source pointer should have to start from the city1. So source should start from city1, and end1 is an address of or the index in which city1 is found. Therefore, source starts from city1, which is Addis, and until it finds the last node, what does it do? It searches using this code. Once it finds the last node, this while loop terminates, and then this is executed. So source has reached the last node. Then finally what we make is source next equals this2. What is this2? This2 is an address of city2. It's an address of city2, which is in our case Khartoum. This is Khartoum, and this is the address of the node holding Khartoum. And this is the time that it takes to fly from Addis to Khartoum. The time taken is this. Okay, so therefore source next equals this2, and directly what we have made is we have inserted, after source reached last node, we have inserted Khartoum next to Cairo. That is here, Khartoum. Therefore, Addis has a flight to Cairo and to Khartoum. What's next? Next is there is flight from Cairo to Bahar Dar, but no flight from Bahar Dar to Cairo or from Cairo to Addis. There is one-way flight from Cairo to Bahar Dar. So what's our first city? City1. City1 is Cairo. What's city2? Bahar Dar. So we have to create a node for city2, and we have to find whether city1 exists in this array. Our city1 is Cairo initially. Our city1 is Cairo, city2 is Bahar Dar. Therefore, we create a node for city2, which is Bahar Dar, and then we find the index of the city1, which is Cairo, whether it is available in the array. If it's available, source should start from city1, from the address of city1, and then it should search the last node. Once it reaches the last node, it should source next equals directory, which is city2. So what this does is this one. First of all, source should start from city1, in our case Cairo. We want to plan flight from flight from okay, I don't know why this is happening anyway. Source. Anyway, source starts from city1 and it searches the last node. Do we have another node next to Cairo? We don't have. Already Cairo is the last node. So we can directly attach a city that has a flight to Cairo next to Cairo. Since Cairo's next is null, since it doesn't have any node attached to Cairo as a flight destination, we can directly attach a city to the Cairo city. Anyway, therefore, since source pointer is at the last node, we can directly make one source next equals city2. How do we know this is city2? This is a pointer that tells us, this is a pointer that holds the address of node 2, which it takes this is a pointer that takes an address of the city2 as a node. Therefore, directly we can insert city2 to Cairo, which is Cairo to Baghdad, which is Baghdad. Okay. Next, from Baghdad to Addis there is flight. There is Baghdad to Addis there is flight. Therefore, our city1 is Baghdad, our city2 is Addis. Now, the source pointer should have to start from city1, which is Baghdad, and it should search the last node of Baghdad so that it can insert Addis next to the last node. But okay, unfortunately Baghdad hasn't any city next to it and the source next is null. Therefore city1 exists within the array and source pointer starts from city1 address, but this is not executed as source next is null. Therefore, directly we make source next equals to destination 2, which is Addis. Addis directly inserted here. Addis. Okay. What else? There is a flight also from Khartoum to Baghdad. Khartoum has a flight from Khartoum to Baghdad, but no Khartoum to Addis. Addis to Khartoum there is flight, but Khartoum to Addis no. Khartoum to Baghdad there is, but no Baghdad to Khartoum. Now we have to implement Khartoum to Baghdad. What is our source cities? Khartoum. What's our destination cities? Baghdad. We have to create a node for this before insertion, because insertion takes place in the form of nodes. This is city1. City1 should have to be proved with city1 existence should have to be proved within this array. Therefore city1 is Khartoum and city2 is Baghdad, and we need to create a node for Baghdad, and the address of that city is destination 2, and our destination 1 is Khartoum. We have to check its existence in the array. If it exists, this part is executed. Before executing this, the source pointer should have to start from the address of Khartoum or city1. Source pointer should have to start from Khartoum. Where is okay now? Okay, Khartoum. source pointer should start from here, from car2, and then it should search the last node so that it can insert bar next to the last node. Unfortunately, Khartoum doesn't have any node next to it, so source next is null. So this while loop is not executed. Directly we make source next equals 1, destination 2. Therefore source next equals to directory 1 bar here, Khartoum to bar. This is bar. Okay, how many flats are there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, 1, 2, 3, 4, 5. Okay, this is directory graph implementation using C++. Pictorially, it looks like this, and the program that implements this directory graph is this one. Okay, this is the graph that implements the whole listing. Okay, if you have any question, please ask me on the comment. Thank you.